In this session, we will discuss about different types of locks in concurrency control. It is quite simple to implement a binary lock. All that is needed is a binary valued variable called as lock, which is associated with each data item in the database. In its simplest form, each lock can be recorded with three different fields. The first field is about the data item name, the second is the lock variable, and the third one is the locking transaction, plus a queue for transactions that are waiting to access the item. The system needs to maintain only these records for items that are currently locked in a lock table. Items not in the lock table are considered to be unlocked. Now the DBMS has a lock manager subsystem which keeps tracks of and control accesses to the locks. If the simple binary locking scheme is to be used, then every transaction must obey the following rules. The first rule: a transaction T must issue an operation lock item X before any read item or write item operations are performed on T. So this is the first rule. The second rule says a transaction T must issue the operation unlock item X after all read item and write item operations are completed on T. The third rule: a transaction T will not issue a lock item on X if it already holds a lock on the item X. And finally, the fourth rule: a transaction T will not issue an unlock item on X operation unless it already holds a lock on item X. So in case you are using the simple binary locking system, then all the transactions must obey these rules. We come to the next topic, that is multiple mode lock. Now, we should allow several transactions to access the same item X if they all access X for reading purposes only. Now this is because read operation on the same item by different transactions are not conflicting. However, if a transaction is to write an item X, it must have exclusive access to item X. For this purpose, a different type of lock called as multiple mode lock is being used. In this scheme, we use something called as shared exclusive, or also called as read-write locks. There are three locking operations: read lock on data item X, write lock on data item X, and unlock data item X. A lock associated with an item X has three possible states. They are read lock, also called as shared lock, write lock, also called as exclusive lock, and unlocked. Now one method for implementing the preceding operations on a read-write lock is to keep track of the number of transactions that hold a shared, also called as read lock, on an item in the lock table. Each record in the lock table will have four fields. First is the data item name, second is the lock variable, next number of reads, and finally the locking transactions. Now again, to save space, the system needs to maintain lock records only for lock items in the lock table. the value or the state of lock is either read lock or write lock. If lock of X is write lock, the value of locking transaction is a single transaction that holds the exclusive write lock on X. If lock of X is read locked, the value of locking transaction is a list of more transactions that hold the shared lock on the data item X. We will have a look at the definition of read lock. So we have a lock variable. So whenever we are accessing a data item X and the status of this lock variable is unlocked, then we change the status of this lock variable to read lock and the number of reads is assigned to 1. Else, when you're trying to read the data item X and the status is already read lock and some other transaction is trying to read this, then the number of reads will be increased by 1. Else we have to wait, that means we are trying to perform an operation other than reading operation. So that in that case we have to wait until the status of this lock variable will be unlocked. Now the next definition is about write lock. Now if the data item is not being accessed by any transaction, that means the status of the variable lock on this data item X will be unlocked. If it is unlocked, then you can change the status to write lock and make some updation to the data variable. Else you have to wait until the status of this variable becomes unlocked. And now finally coming to the definition of unlock. If the status of the data variable lock is write lock, then you release the lock on the data item X and make it unlocked. Else if it is read lock, then you have to go on releasing all the transactions that were reading from this particular data item. That means you have to keep on decrementing one by one until the value of read becomes 0. So once it is 0, then you change the status of the variable to unlocked. So we have seen the different definitions of read lock, write lock and unlock. Now when we use the shared exclusive locking scheme, the system must enforce the following rules. The first rule: a transaction T must issue the operation read lock or write lock before any read item X operation is performed on T. The next rule: a transaction T must issue the operation write lock before any write item X is performed in T. The third rule: a transaction T must issue the operation unlock X after all read item X and write item X operations are completed in transaction T. The next rule: a transaction T will not issue a read lock X operation if it already holds a read lock or write lock on item X. The next rule: a transaction T will not issue a write lock X if it already holds a read lock or write lock on that item X. And finally, the last rule: a transaction T will not issue an unlock operation unless it already holds a read lock or a write lock on an item X. So in case you are using the shared exclusive locking scheme, then you must make sure that you enforce this set of rules. Next, conversion of locks. Now it is possible for a transaction to issue a read lock and then later upgrade the lock by issuing a write lock operation. Now if T is the only transaction holding a read lock on the data item X at the time it issues the write lock operation, then the lock can be upgraded. Otherwise, the transaction must wait. Now it is possible for a transaction T to issue a write lock X and then later to downgrade the lock by issuing a read lock operation. When upgrading and downgrading of locks is used, the lock table must include a transaction identifiers in the record structure for each lock. To store the information on which transaction hold locks on the item. So basically you can upgrade locks and downgrade locks. Next is guaranteeing serializability by two-phase locking. A transaction is said to follow the two-phase locking protocol if all locking operation, that is read lock and write lock, precede the first unlock operation in the transaction. Such a transaction can be divided into two phases, as an expanding or the growing phase, during which a new locks on items can be acquired but none can be released. This is called as the expanding or growing phase. And a shrinking phase. In this phase, the existing locks can be released but no new locks can be acquired. If lock conversion is allowed, then upgrading of locks from read lock to write lock must be done during the expanding phase, and downgrading of the locks, that is from write lock to read locks, must be done in the shrinking phase. So basically in this two-phase locking mechanism, we acquire in the first phase, which we call as the expanding or the growing phase, we acquire all the locks, and in the second phase we release all the locks. So that is why it is called as two-phase locking mechanism. Now here we have an example, transaction T1 and transaction T2. Now if we convert this into a serial schedule and we follow assuming that the value of X is 20 initially, Y is 30 initially, and we execute T1 first and T2 later, then the value of X is 50 and Y is 80. Whereas if we change the serial schedule, that is we execute T2 first and then T1, then we get different values of X and Y. Now here what we are doing is I am trying to have them into a non-serial schedule and trying to use the read lock, write locks and the unlock mechanism over here. Now in this example, it does not follow the two-phase locking protocol because the write lock X operation follows the unlock Y in transaction T1. Similarly, the write lock Y operation follows the unlock X operation in T2. So because of this, it does not follow the two-phase locking protocol. So in case if the schedule is to be in two-phase locking protocol, then it should be into two phases. One is the expanding phase and then is the shrinking phase. So in the expanding phase, all the locks should be acquired, and in the shrinking phase, all the locks must be released, which is not happening in this schedule. Now there are different types of two-phase locking mechanisms. The first one called as conservative two-phase locking mechanism. Okay, also called as static 2PL. PL stands for phase locking. Okay. Now in this two-phase locking mechanism, it requires a transaction to lock all the items before the transaction begins with its execution. So basically it has to pre-declare its read set and write set. That is why the name static 2PL. The next type of mechanism is called as strict two-phase locking mechanism. Now in this method, a transaction T does not release any of its write locks until after it commits or aborts. Hence, no other transaction can read or write an item that is written by T unless T has committed. Now this mechanism makes it a strict schedule for recoverability. And finally, we have something called as rigorous two-phase locking mechanism. Now in this, a transaction T does not release any of its lock, either it is read lock or write lock or an exclusive lock or a shared lock, until after it commits or it aborts.